So in the previous movies, we were looking at forcing an air parcel from one height to another one. We ran into a particular case that I said I would address later, and this is where I'm going to address it. And that's this layer at 2 kilometers, and kind of what to do with this case. So for example, and let me tell you what the problem is. So if I have the parcel temperature and the parcel dew point, and I start at 17 degrees and 16 degrees for the temperature and dew point, and I take this parcel and I force it up to the next level. It's not saturated, so we'd think that we would have 12 degrees. I'm putting a question mark there because it's not actually the right answer. Cooling at the dry rate, which would be 5 degrees for every half kilometer. The dew point lapse rate is 2 degrees every kilometer, or 1 degree every half. So this would cool to 15. It would drop to 15, and I would do a question mark. Now the reason why this is a red flag is because suddenly we can see that the dew point is greater than the temperature. So we have that problem, which means that this cannot be the right answer. Okay, so that just can't be the right answer. But what happened here was somewhere between 2 kilometers and 2.5 kilometers, we ended up being saturated. So how do we figure out at what height that is? All right, so I'm going to clear this, and then we're going to go back to and kind of expand this. So we have 17 degrees temperature and 16 degrees dew point. So this is the temperature and this is the dew point. Okay, and we're lifting up, and initially at least we are going to be cooling at 10 degrees every kilometer for the dry rate, and the dew point's going to drop by 2 degrees every kilometer. And so but at some point, at some change, some h, okay, these two numbers, these two temperatures, the temperature and the dew point, are going to be equal to each other. So at this point, somehow 17 degrees minus 10 degrees every kilometer for how many kilometers? We'll just call it h. And the dew point is 16 degrees minus 2 degrees every kilometer times the same h in there. And at some point, at some value of h, these are going to be equal. And so we can solve this by going and just, bringing all the h's over one side, bringing all the temperatures over one side. So I end up with 17 degrees minus 16 degrees is equal to 8 degrees per kilometer times h. That's the 10 minus 2. And so then I'll simply get h is equal to 1 degree over 8 degrees per kilometer, or 1/8 of a kilometer. So at 1/8 of a kilometer up, we end up with the same temperature and dew point, and 1/8 is about 0.125 kilometers. Okay, so in terms of a change, what will be the temperature at that? Well, the temperature will be 17 degrees minus 10 degrees per kilometer times 0.125 kilometers, or 17 minus 1.25, and it will be at a height. So at a height of above 0.125 kilometers above, the new temperature up here will be equal to 15.75 degrees. The dew point will also be 15.75. So and then we have another half a kilometer to go, and we're going to cool at the saturated rate. So excuse me. So let me clear this out. Again, 17 degrees, 16 degrees for dew point and temperature. If we go up 0.125 kilometers, we end up with a temperature equal to 15.75 degrees and a dew point of 15.75 degrees. Okay, we go up by another, we have half a kilometer minus the 0.125 that we have, so another 0.375 kilometers, that this whole height will be 0.5 kilometers. So we cool at this point, we're going to cool at the saturated rate, 6 degrees per kilometer. And so now the new temperature will be, at the top, 15.75 degrees minus 6 degrees per kilometer times 0.375 kilometers, and it'll be equal to, so 15.75 minus 6 degrees times 0.375, 13.5 degrees. So it'll be 13.5 degrees, and the dew point will just simply follow that up. So the dew point will also be 13.5 degrees. And so now we can go back to our table and find that if we go from 17 degrees and 16 degrees, and we bring this up to the next level, we're going to have 13.5 and 13.5. And in doing so, we can see now from a stability analysis that this is, compared to the environment, is warmer than in the environment, and so we'll keep going up, and that means this level at 2 kilometers is unstable. So that's about the hardest example you're ever going to get here, simply because it switches from dry to unsaturated to saturated in the middle of lifting. But again, it's the same. It's the same idea.